Right, so I'm going to work through the 10.1, 10.2 review worksheet. This is a good place to start if you have any questions on anything related to this worksheet to get ready for your quiz, your 10.1, 10.2 quiz, okay? So find the measure of QR. Well, QR has a mark like this, which is the same as the mark with RS. I know the measure of RS is going to be 40 degrees because the intercepted arc and the central angle have the same measure. So if this central angle is 40, this arc is 40. So then QR would also be 40 because they have the same mark here. So this is 40 degrees, okay? Find the measure of arc SPU. So S to P to U, right? This whole arc here. So we're going to have to add up some numbers. So we know 40, 40, right? So I want to find this one right there. Well, I know this is 90, so I could add these up. I need to figure out what's left over for this angle here, right? So to get this angle, I can say 360 minus 130 minus 40 minus 40 minus 90, and I'm going to divide that all by 2 because these two are going to have the same measure, right? The only angles that are left over are these two, right? And when I do that, I get 30 degrees for these angles. Now that I know those are 30, I can add this up. 130 plus 30 plus 40 plus 40. And if I add all that up, I get 240 degrees. All right, the measure of TUS. Let's go with a different color. T to U to S. So now this whole bit here. So pretty much anything but the 90 degrees right there, right? So I can just say anything but 90, so 360 minus 90, and we get 270 degrees. All right, last bit, PQ. Well, we know the central angle is 30, so the arc is also going to be 30, so 30 degrees. Cool. All right, find the area of the shaded region round to the 10th place. So to get the area, you do the fraction of the circle, so degrees over 360 times the equation for area of a circle, pi r, pi r squared. Awesome. So I see for the shaded region, the degrees is 38, so 38 out of 360 times pi times 10 squared. Now I can plug this whole thing in my calculator exactly like this, right? And if I plug this whole thing in, I get 33.2 units squared. Okay, we'll do it again here. Degrees over 360, so 73 over 360 times pi times 32 squared. Again, we're rounding to the 10th, so we can plug that whole thing in our calculator, and we get 2,564.7 units squared. All right, last one. Here we're finding a sector. So to get a sector, we do like this whole thing, but then we take away the triangle, right? So to get a sector, we're going to do this whole like pi wedge, okay? So we're going to do degrees over 360 times pi r squared. That'll get me this whole thing right here, right? But then I want to take away the triangle. Now to take away the triangle, I don't know a base and a height, so I'm going to have to use the equation 1/2 a times b sine c. Okay, because we don't know base and height, this is the equation we have to use. So now I'm going to plug everything in. 120 over 360 times pi 4 squared minus 1/2 4 times 4. Both of these will be 4. Sine 120. And again, I should just plug that whole thing directly in my calculator. like this, and I get that the area is 9.8 units squared. Cool. All right, find the length of GF, or the length of GF is 4. What is the radius? So for the length of an arc, the equation for length of an arc is the fraction of the circle, so degrees over 360 times the circumference, 2 pi r. So here we know the length. We know that length is 4. I'm going to do degrees over 360 times 2 pi r. R is what we're looking for, right? Well, to solve this, I'm going to start by dividing by 2 pi on both sides. When I divide by 2 pi, I get, well, that 4 over 2, that fraction reduces to 2 over pi, equals 32 over 360 times r, right? Next, I'm going to multiply by the reciprocal fraction to get rid of this fraction here. So I'm going to multiply both sides by 360 over 32. And that will allow me to just have r left on this side, right? And if I do that, so 2 over pi times 360 over 32, I get 7.8. So r equals 7.8 meters. Okay? Or sorry, I didn't get 7.8. I should have got 7.2. Nice. All right. What is the area of the sector bounded by GF? So now I'm finding what is the area of this, right? Well, we know the radius, so I can just say area equals 32 over 360 times pi times 7.2 squared. Equation for area, which gets me 14.5 meters squared. All right, next one. A pizza with a radius of 7 inches is cut into 12 equal-sized pieces. What is the area of each piece? So we have a pizza, right? And it's cut into 12 equal-size pieces. This is not the best, but something kind of like that, right? Cool. So what is the area of each piece? So we want to find an area of a single piece, and we're going to assume they're all the same, right? So the radius is 7, and to do this, I'm going to say area equals, now this piece is 1/12, right, of the whole thing. So I can say this is just 1/12 here, or I know that I can do 360 divided by 12, which is 30, right? 30 over 360 here is the same as 1/12. Okay, pi times 7 squared. Plug that in my calculator, I get 12.83 inches squared. Cool. All right, next one. Segment AB is tangent to circle C. Find each value. AB. So we want to find this length right here, right? We know it's tangent, so if it's tangent, this is going to be a 90-degree angle. I see that this is 8, so this is also 8, right? So we need to find this length right here, okay? We're trying to find this. Well, this whole length is 16, which happens to be twice as big as this one. Right? So I could use Pythagorean theorem. Maybe you know what that length is already. I'd say x squared plus 8 squared equals 16 squared. I'd get x squared plus 64 equals 256. Subtract 64 from both sides, and I get 192, right? And then I need to square root and simplify. Well, 192 happens to be a product of 64 and 3. And then the square root of 64 is 8 root 3. This triangle may look familiar to you, 8, 16, 8 root 3. This would be a 30, 60, 90 triangle. So maybe you saw that relationship and you just knew that was going to be 8 root 3. So this is 8 root 3, right? So you could write it that, or if you did 8 times radical 3, or you didn't leave it in radical form to begin with, you'd get 13.86 about, right? What is the measure of angle ABC? Well, we knew that from the beginning. That was going to be 90 degrees. All right. JF and GH are tangent. Now, if they're both tangent, these are 90, right? And then these are equal. So I can say 4x minus 4 equals 3x. Okay? I need to solve for x so I can find the length of HJ. So to do that, I'm going to subtract 4x and get negative 4 equals negative x equals 4. Okay? So if x equals 4, I'd plug that back in to get this length HG. 4 plus 1 is 5. These are both radii, so this is also 5. So HJ equals 5. Okay? Right, so all these are tangent to the circle. What is the perimeter? So kind of like up above, if these are all tangent, I know these segments are equal. I know these segments are equal. These are equal. And these are equal. Right? So now I'm going to fill this in. If this is 3, this would be 3. This is 4, this is 4. This would be 10, and this would be 6, right? So to get the perimeter, I can do 2 times 3 plus 2 times 4 plus 2 times 10 plus 2 times 6. And I'd calculate all that, and I'd find out that the perimeter is 46. All right, last one. RP and TP are tangent to these circles. What is the length of RP? Cool. So I see that this is 81 and this is 20. We know they're tangent, right? So we should be able to find this length right here pretty easily using Pythagorean theorem because we have a right triangle. So I'd say 20 squared plus b squared equals 81 squared, right? I'd get 400 plus b squared equals 6,561. I'm going to subtract 400 from both sides and then square root both sides. So I get that b is 78.5. Well, these total length, this would also be 78.5, right? Well, these total lengths are equal. So that means this is 66, right? So RP is 66 plus 78.5. And I get 144.5. Great. Well, email me with questions. Again, I hope you guys are well. Talk to you soon. Good luck on your test.